In this video, I'm going to be working a multivariable calculus quiz over local extrema. So we're going to be using the second partials test a lot. And so first, we're just going to determine if there's a minimum, maximum, saddle, or insufficient information to determine the nature of the graph of f at one of its critical points, 1, 1. All right, so they're just telling us it's a critical point, and we're going to run the second partials test right here. All right, so if I've got these, and I know it's a critical point, I just need to compute that number. We call it D because it's the determinant of the Hessian matrix. But D is going to equal fxx, I'm going to write it out, fyy minus fxy squared. Okay, and then that's going to equal fxx is 4, fyy is 6, minus fy squared would be 25. That's going to equal -1, and because that's a negative number, I'm going to conclude that I have a saddle point. Okay, now we're just going to find the critical points of this one. Okay, so fx is equaling 2x plus 4y squared. And then fy is going to equal 2y plus 8xy. Okay. Oh yeah, I kind of remember this one. Alright, so in order to find where these critical points are happening, we need both of these derivatives to equal 0 or one of them to non-exist. And both of these are always going to exist for any x and y. So what I need to do is think about where these equal 0. So I'm going to set this one on the right to 0 because I notice I can factor this. I can factor out a 2y, and I'd be left with a 1 plus 4x. Alright, so fy will equal 0 if either y equals 0 or x equals -1/4. Okay, now on this one, okay, but one of those has to be true in order for, fy to equal 0. On the other one, if I set this equal to 0, basically what I would get is that x equals -2y squared, right? If I just set it equal to 0, divided both sides by 2, and subtracted away the 2y squared. All right, so if x equals -2y squared, then we would be having fx equals 0. So I've got these two kind of numbers in red that I'm going to work with. I'm going to say first, what if y equals 0? Okay, that means x needs to equal 0, so that's going to be a critical point. And then also if x equals -1/4, okay, that would, I'm going to need to do a little bit of algebra here, but -1/4 equals -2y squared. So I might divide both sides by -2 and get, let's see what that'd be, an 1/8 over here and 1y squared. And so y could be the square root of an 1/8 when x was -1/4. Okay, so I would say my critical points are going to be x equals 0, y equals 0, and also x equals -1/4, and y equals the square root of an 1/8. And I'm just realizing that there was nothing to say that y couldn't be negative, and I took the square root of both sides of the equation, so I would need plus or minus. So I'm going to need, more room, I think. All right, so square root of 1/8, and then also -1/4, and the negative square root of 1/8. Okay, now we're going to find all the locations of extrema and saddles on the graph of this function here, f. Okay, so I'm going to need to take the partial derivatives first. Fx is going to equal 3x squared minus 12y. Then fy is going to need to equal -12x plus 3y squared. Okay, so 3y squared minus 12x, 3x squared minus 12y. These need to both simultaneously equal to 0. Let's think about the one on the left. Yeah, sure. Okay, so if 0 equals 3x squared minus 12y, then y is going to equal 3 over 12, 1/4 of x squared. And that would give me fx equaling 0. If that happened, yes, yeah, because then I would have 3x squared minus 3x squared. That would give me 0 for sure. Okay, but not really anything more than that. Okay, over here, I would have fy equaling 0 if x equaled 1/4 of y squared. And this has got a lot of symmetry to it, mostly because the original equation f has a lot of symmetry to it as well. I think what I'm going to do, I'm just going to substitute in on y, right? I've got y equaling 1/4 x squared over here, and a formula that has y in it over here, so I'm just going to see x equals 1/4 of 1/4 x squared. And all right, so that's going to be 3 powers of 4 is going to end up being 64, and then x to the 4. Now, let's see. If x equals 0, because I'm about to divide both sides of this equation by x. If x is equal to 0, then y would need to equal 0, and that's going to be a critical point. So I'm going to, list that off to the side. 0 and 0 is going to be a critical point. But if x is 0, there's not really any other ways that we could get a critical point. Yeah, except for y equaling 0. So I am going to be able to just confidently divide both sides by x here and get 1 equals, or maybe I'd divide both sides by x and multiply both sides by 64 and get 64 equals x cubed. And that's going to give me x equals 4, and then x equals 1/4 of y squared, which is also going to need to be 4, and it would make sense that I would get a point with the same x and y coordinate, based on the symmetry of the equation. And so 4 and 4 here, and those are going to be my 2 critical points. And I am going to clear out the work in blue that I needed to find those, because I'm going to now need my second order derivative. So I'm going to have fxx equaling 6x. I will have fyy equaling 6y, and then I will have fxy equaling -12. Okay, either way you look at it, right? And so having this and thinking about my 2 critical points, first I might think about 0, 0. At 0 and 0, if I take, fxx, fyy minus fxy squared, well, fxx and fyy are both going to be 0, so I'm going to be taking, actually maybe I'll just show it, but I know it's going to be a negative number and therefore a saddle. So that determinant is going to be 6 times x, which was 0, times 6 times y, which was also 0, minus fxy, which was -12 squared. Okay, well, I'm still subtracting 144, and so that will be -144. Okay, and that's less than 0, so I conclude there is a saddle point there. Okay, but at x equals 4 and y equals 4, I think I'm going to have an extrema. Yeah, definitely. I know I will. It'll be obvious. Because when I go to compute this number here, I'm going to have 6 times 4 is 24, times another 6 times 4 is 24, minus -12 squared, which is going to be the same as 12 squared. And I've got 24 squared minus 12 squared, which is definitely a positive number. So that means I've got an extremum. Okay, if I've got an extremum, then fxx and fyy will both have the same sign. I look back over here, I think they were both positive. So if they're both positive, that means I've got a local minimum. Okay, so that's like fxx and fyy both being greater than 0. All right, now the last one is asking how many critical points does this function have? Okay, well, say I'm going to have to take the partial derivatives, so derivative of f with respect to x is going to be 2x plus 12xy. Don't love the look of that. And then fy, that'll be a little bit better. No, not much. That's going to be 2y plus 6x squared. All right, so what I'm going to do is, this is kind of like the first one I did. going to go over to this side on the left and say, okay, if fx is going to equal 0, I could factor out 2x, and I'd be left with 1 plus 6y. Okay, and so fx will only equal 0 if either x is equal to 0 or y is equal to negative 1 over 6. Okay, and then I go over here to this equation and say, all right, well, I need, when x equals 0, say, I'm going to need fy to equal 0. Let's switch to color red. So fy needs to equal 0. That's going to be 2y plus 6 times x equals 0 squared. Okay, that just means y has to equal 0. And I've got a critical point at x equals 0, y equals 0. And then if I was to say, okay, fy needs to equal 0, but that could happen when y was negative 1 over 6. So 2 over negative 6, that's going to be negative 1/3. Plus 6x squared, that is going to need to equal 0. And so if I go and add 1/3 to both sides, I'd have 1/3 equals 6 times x squared, divide both sides by 6, get an 18th equaling x squared, and then x could be plus or minus the square root of 18. And since I kind of forgot that the last time, I do think I should write that out. Okay, and then my other two critical points. So there are going to be 3, but I'm just going to show them. Positive square root of 1 over 18, and then y needs to equal, what was it, negative 1 over 6. Or I could have the negative square root of 1 over 18 and negative 1/6. Okay, so those 3 critical points. And yeah, that's the end of the quiz, so that's going to be all for this video.